my simple one-dimensional example again. Okay, before I start upending your little worlds.
Please don't.
If I'm walking this way at an instant velocity, I'm defining my terms carefully so Parker doesn't jump all over this, okay? See how well I do. All right, if I'm walking this way, but I'm slowing down, walking this way, but I'm slowing down, my displacement is moving in this direction.
Yeah.
My velocity is moving in this direction.
No,
But if I'm slowing down, which way is my acceleration going?
that way.
My acceleration's that way if I'm slowing down. Still just one-dimensional. Let's take this to 2 dimensions a little bit. So displacement and velocity, same direction. Acceleration, maybe not. Let's take this from 1 dimension to 2. Acceleration. This has always been true, but in 1 dimension it hasn't mattered. Acceleration is a change in velocity, and a change in velocity can mean a change in your speed or direction, or both for that matter. Acceleration can be a change in your speed or your direction, and that is still an acceleration, even if you don't change your speed at all. Yes, sir. You have a thought. Okay. It's a good thought, I hope. Hang on 1 second. What's the tip of the cord doing?
Going really fast in a circle.
Going in a circle. Do you think its speed is changing? I mean, I'm screwing it up because I'm holding it funny, but okay. I'm trying to keep it moving.
If
Do
you
the
did
same
it right,
thing.
it would be the same.
Yeah, if I were doing it right, do you think the speed would be moving?
No.
No, speed's not supposed to be moving. Is its direction changing?
Constantly.
Constantly, every single second. This is
It's
a
still
constant.
going that way.
Well, I'd say this is a constant acceleration. This is accelerating every single instant as it moves around the circle. Who was it who said that? Sasha, you said something about a circle, describing a circle as an infinite number of lines instead of a circle.
Oh, I did the thing of the line. The
Yeah.
vector is in a line.
Yeah.
Right.
So this is a circular motion. That means that Parker is getting hypnotized by it. So this is a circular motion. You guys know what a sling is?
Yeah, like slingshot.
That's a slingshot. The original sling was just 2 strings with a pouch. You put a rock in the pouch, spin it really fast, and let go of one of the strings at the right time.
Yeah.
The rock goes. Anyone familiar with the Old Testament story of David versus Goliath?
Yeah, he had like one of those things that just
Yeah.
threw it.
They decided to settle this war by single combat, so the enemy, I don't remember what tribe, sends out Goliath, from which we get the name Goliath, meaning huge, and this huge giant guy, and David's like, I can't take him, so he doesn't go out in armor with a sword, he goes out with like...
I thought it was a line.
That's a different one. Different story. So he goes out with like a t-shirt and a sling, and Goliath's like, this guy's not even wearing armor. I'm going to rip him to shreds. And David takes his sling, lets go at just the right moment to catch Goliath right between the eyes. Dead giant. Victory for the future King David. Interesting Old Testament story. It's spawned many, many metaphors. Here's a tiny bit of the physics of that. I'm going to ask one question first. See who knows this. Depends on how much I have to say next. If I want to send to the rock at the end of this, I can't even hold it. The cord is tangling as I do it. If I want to send the rock at the end of this sling flying straight away from me, when do I have to make sure the rock is released?
Right at the tip.
When it's over, when it's further
No, it's
on
right
that
here,
side.
I'd say.
Right at the highest point.
Yeah, that's
Right at the highest point.
Oh.
Here's the deal.
If you let it go here, they just go up.
I don't know what I'm talking about.
Curved motion. Curved motion. Here's the first deal about curved motion, okay? The velocity vector is tangent to the curve. The velocity vector is tangent to the curve. Okay? So if we have our circular motion there,
Tangent to the curve? Like,
yep, tangent to the curve. Tangent meaning Latin for touch. Also, the velocity vector is also tangent to the curve. So if I want the sling to have a displacement that way and a velocity that way, I have to let go at the top. And that might be my velocity vector. If I'm spinning this at the same speed, then anywhere in my spin, there's a tangent velocity vector of the exact same length. Okay? Now, if I'm walking in a straight line and accelerating, the acceleration vector could be drawn parallel to the velocity vector. But this thing wasn't changing speed, it was changing direction. In which way was this thing changing direction?
It's going circle
Yes, you're right, it was going circle-wise.
It's going
That's-
around.
It's going around, but think about this a little bit.
Wait, what was the question?
In which way is it changing direction? Which way is this changing direction?
right and left.
Right and left. Okay, let's pretend that you're driving, that you're in this little spaceship up here. I don't know. Okay? And let's
So are
pretend,
like-
Is it going forward and
Constantly.
backwards?
sort of, but let's pretend that you're sitting here, okay, and you're sitting upright this way. You got that? So you're driving it like this. You got that image, Sasha?
Kind of.
Okay, so you're sitting there driving it. In order to move in a circle, which way are you turning the wheel? To the right or to the left?
To the right.
You're turning it to the right. Yeah, to your right. To keep it moving in a circle like that, how often do you have to turn it to the right?
Once, you just have to keep it
Constantly.
held.
But then you have to hold it there, or as Connor phrased it, you're constantly turning it to the right by holding the steering wheel that way, right? So there is a constant turn action to circular motion. So my acceleration vector for a perfect circular motion would be a right turn in towards the radius.
Why? Okay.
Because in order to keep moving in this circle, assuming I was sitting upright like this to the board, I'd have to keep turning to the right to keep creating this, to keep making this happen.
But
Does that
why
make-
is it going downwards?
Well, because if I turn to the left, I'm not going to go in the circle. I'm going to go flying. I'm going to go to the left. This is to keep me turning this way.
Okay, I got it.
Does that make sense?
Yeah.
Okay. So the velocity vector and displacement vectors have to be in the same direction. In just one dimension, just walking along a line, the acceleration vector can be moving with you or against you. In 2 dimensions, the velocity and displacement still have to be going in the same direction, but the acceleration vector can be going anywhere. And that will just cause you to follow a curved path. Does that make sense? That should roughly get you started on either tonight's or tomorrow night's homework.
Does that
I forget if I put one of these in there. It's online with a date in the wrong place. I have tonight's homework for Monday. So I need to fix
But
it.
you don't have Monday's homework up then? Of what was due yesterday that I...
No, I don't have Monday's homework as what was due yesterday, so I'm going to change this. But the homework for tonight is page 78.
But you brought your computer for once.
I did. 25 through 28.
Do you still want recording?
And now we're done.